Section 1.2 is on integer exponents. First, we need to discuss what an exponent actually means. If the exponent is a positive integer, we can think of it representing the number of times we multiply the base times itself. So if we have a number, say 2 to the third power, 2 is called the base, 2 is the base, and 3 is the exponent. And this means we multiply the base by itself 3 times. So 2 times 2 times 2, and altogether we get 8. So that's what we mean by an exponent. If we continue to think of it in this way, our exponent rules are going to make more sense. So continue to think of it as a base multiplied by itself the proper number of times. Well, what about negative exponents then? Because this is supposed to be integer exponents, so positive, negatives, and zeros should all count. So what about negatives? Well, let's take a look at a few things. Let's start with looking at, okay, we just said 2 to the third was 8. 2 squared, what is that? Well, if we recall, that's 2 times 2, so that's 4. 2 to the first power, that means we write 2 times itself one time, so we just get 2. So what should 2 to the 0 be? Well, either you remember the rule that 2 to the 0 power, anything to the 0 power is 1, or you take a look at the pattern. Every time, what am I doing here? I take 8, I'm dividing by 2 to get 4. I divide by 2 again to get 2. So if I divide by 2 again, I'll get 1. So anything to the 0 power is always 1. Any a to the 0 power is always 1. So now what happens if I go down one more power? 2 to the negative 1 power. Well, the pattern says divide by 2. So there we go, 1 over 2. What about when I go to the negative 2 power? Now I have 1/2 divided by 2. Well, go back to those rules from last section. This means multiply by the reciprocal of 2, which is 1/2. So we get 1 over 2 squared. And in that case, of course, we know that that's 1 over 4. That's 2 squared is 4. So any negative power can actually be represented in one concrete formula. In general, we have any real number a to any integer power. If it's negative, that's the same as writing it as 1 over a to the positive n power. And that's likewise if this was actually a negative inside of there, all of those rules apply. So you just take the reciprocal of it. That's what it really means. Now let's take a moment to go over some laws of exponents. You might want to have your notes handy from the outline just to keep track of these as we go forward, or write them down as we go along for when we do the examples later. So if we take a to the m and multiply it by the same base a to another power n, doesn't matter if those powers are the same, but the bases must be, then what we need to do here is think about it this way. A to the m power means writing a times itself m times, and we're supposed to multiply by a times itself n times. So altogether we have a times itself m plus n times. So there's the rule. If the bases are the same, we add the exponents. What about if we divide? Well, think of it the same way you did this. If we divided by a n times, we would actually end up subtracting the exponents. Or you can also think of what else this means. So remember, 1 over a to the n is really a to the negative n, and then we're adding those together for the rule. Either way you think about it is fine. The next rule is something we often call a power to a power. So instead of having a second base in existence, we only have one base raised to a power and then raised to another power. What are we going to do here? Well, again, we're thinking about that as what does the exponent mean? The first one says take a and raise it to the power to it, or multiply it times itself m times. Then we're going to write that n times. So altogether we're going to have m times n times. It's applying the definition of the exponent twice. The next law applies when we take two different bases. We're multiplying a times b and raising it to the m power. Note that there's multiplication between these. In that case, we can rewrite this as a to the m power times b to the m power. So we can raise each of those individually. Note that this, again, this is multiplication between them, not addition. Does not apply for addition. Likewise, if we have division and we raise it to the m power, we can rewrite that as a to the m divided by b to the m. Not subtraction or addition, but in multiplication and division it works. The sixth rule is dealing with a negative power here. Well, really what we're doing is we're saying the same thing. Think about what we've already talked about, the negative exponent. That means we're going to take the reciprocal of it, and then according to rule number 5, we're going to raise each of those to the m power. So that's that sixth rule. And the seventh rule has to do with having different powers, but again, it's just invoking that definition of a negative power. So a negative means take the reciprocal. So instead of being in the numerator, this guy's going to be in the denominator with a positive number here. And the b to the negative n, instead of being in the denominator, it's going to go upstairs in the numerator with the positive power. So that's the seventh law. At this point, I advise you stop the video if you can and go and try a few simple examples such as the pre-quiz if you haven't done so already, or some of the initial starting questions of the homework for this section. As we go forward, if you continue with this at this point, let's do a more complicated example. So I'm going to write this down. This is going to take us several steps to complete this, and like I said, this is a more complicated example just to get all of these ideas flowing into one. So the first thing I'm going to do is I'm going to think about what this negative power does to everything. It's going to take the reciprocal. So the first thing I'm going to do is put everything that was in the denominator up into the numerator, and everything that was in the numerator down into the denominator. And that's still raised to the third power. The next thing I'm going to do is deal with all the negatives inside of here. So x squared's positive, it's fine, we're going to leave it alone. Y cubed, that's a positive power, we'll leave it alone. But the negative 4, that means I'm going to put that downstairs. So the x is going to get left alone, and we're going to have a z to the 4th. So x was left alone, y to the negative 2, that means it needs to be bumped up here. We'll deal with putting them together in a second. And the z cubed goes up here. And don't forget that we still have that cubed. So let's go ahead and combine those. X squared, y, remember we have two bases, so we add those powers together. All over x z to the 4th. And we're still raising that to the third power. Now, just because I want to make my life as simple as I can, I'm going to cancel everything first. So let's look here. All of this is multiplication. So we're allowed to use our little rule from before. X squared over x. That means I have x to the 2 minus 1 power, or just 1 power. There's no y to the 5th or y's in the bottom, so we won't deal with that. And z cubed and z to the 4th. So 3 of those cancel, and I'm left with just a z in the bottom. And I still need to cube it. So now that we've gotten everything simplified that we can inside, let's go ahead and cube it. So that means we distribute a power of 3 to each of these. 1 times 3 is 3. 5 times 3 is 15 here. All over z cubed. And that's going to be our final answer. Like I said, lots of steps going on here. But if you see each part individually, we're just going to deal with each of those things as we go along.